Today's lesson is 1.2 Relations and Functions. A relation is a comparison of two or more sets of values. A function is a relation with where each input, remember my inputs are my x's, number corresponds to one and only one output, my y number. So my x cannot repeat. If my x goes to more than one y, okay, or my x, I see two of my x's, then I am not a function. I'm a relation, but I'm not a function. Okay, so let's go ahead and take a look at example one. We're going to provide the domain and range and identify each relation as a function or not a function. If it is not a function, we're going to explain why it is not. So we can define the domain and range even for a relation. What we're basically practicing is which ones are the x values and which ones are the y values. That's all the domain and range does. So let me go ahead and change this to a blue and a green so that we can talk about the domain and the range. Now remember that your domain are your x values and that your range are your y values. And remember, when you have a set of ordered pairs, each ordered pair must have an x and a corresponding y. That way we know how to find them on the grid, on the xy axis. And so when I look at my ordered pairs here in example A, all of the first numbers are going to be my x values. So let's just go ahead and put an x under each one. When I go ahead and state my domain, I'm going to start with a little curly bracket, do the best you can, and then you're going to put your domain numbers in order from the smallest to the largest. If there are any repeats, you just only put it once, okay? You don't have to show me that there are 5 6s, okay? All you have to do is put one of them. So the smallest x that I see is 2, and then I'm just going to go comma. The next smallest one I see is 3, and then 4, and then 5, and then 6. I don't see 7, but I do see 8. And that's the last one, so I'm going to go ahead and close it up. Now let's go ahead and find our range. These are going to be all our y values. All my second numbers inside of my ordered pairs are my y values. Same thing, I'm going to put my little squiggle and I'm going to put my range numbers in order from smallest to largest. If there is more than one, I only have to put it once. Now I see that there is a 2, so I'm going to start with the 2, comma. I see a couple of 4s, so I'm going to put 4 next, then 6, then 7, and then 8. So notice that my range is a little bit smaller than my domain. That is okay, and that is because notice right here I have a 4, and then again I have a 4 right here. But I only have to put that 4 once in my domain. In my range, I don't have to put it twice. All right, is this a function? To know that it's a function, you just cannot have your x value repeat. So what I'm going to do is I'm going to count my ordered pairs, 1, 2, 3, 4, 5, 6, and I'm going to count my numbers in my domain. If there are 6, then it's a function. 1, 2, 3, 4, 5, 6. They match. This is a function. If I had done 1, 2, 3, 4, 5, notice they wouldn't match, right? Does that make sense? They're not, that would be not a function, but it's x. X is the one that tells you you are a function. So count, if they match, then it's a function. All right, here we go. Let's take a look at this one, and there should be some lines in here, so let me go ahead and add them real quick. These are called a mapping. So what I'm doing right now is I'm telling you what these points go to, okay? What these points go to. There we go. And then the second one, the mapping, it's just symbols, but There we go. There we go. There we go. Okay, there we go. Now, when I have a mapping, if you remember, the first ones are always my X, so there would be my domain. My domain, I could put just a capital D. My domain would be A, comma B. Notice there's another A, comma C. There we go. And the second one would be considered my Y, so these are my range. And if I put them, I would put A, comma B, comma C, comma D. Is this a function? Remember, you're counting your X's. 1, 2, 3, 4. 1, 2, 3. Is 4 equal to 3? No, that's not true. 4 and 3 are different numbers. Not a function. Why? Why is this not a function? This is not a function because the letter A repeats. The letter A is going to the letter B right here. The letter A is going to the letter C right here. Not a function. All right, let's take a look at the one with the symbols. And I'm not going to write down the domain and range for two reasons. One, I don't want to write the symbols. And two, I really don't have any space. So let's go ahead. Here would be my domain. Take a look. Are all the symbols different? There are 4 of them. Are they all different? Yes, they are. So I'm going to go ahead and say that, yes, this is a function. Here would be your range values. And yes, they are the same for symbols, but it doesn't matter. You could have one of them that's not even used. It's still a function. So this one is a function. I don't see any double arrows. Like if I had seen something like this, now that's not a function because I see 2 arrows coming out of that first symbol. But because each symbol only contains 1 arrow, this is a function. When I get the double arrow, that's when I'm not a function, okay? All right, let's take a look at a set of ordered pairs like this. Remember, you're just looking at your X's. And then that's your domain. And then your Y's, your range, would be the second ones. All right, so let's go ahead and decide if this is a function or not. Remember, when you are deciding if it's a function, you're looking at your domain. You're looking at your X's. There are 1, 2, 3, 4, 5 different groups, and you have to make sure that all 5 of these gentlemen's names are different. So notice I have Jim. Then I have Joe, that's different. Then I have Brian, that's different. But then take a look, Jim shows up again. Is this a function? No. It doesn't even matter that Ken is a different name. This one is not a function. And it's because we have Jim and Alice, and it's because we have Jim and Kitty. So the reason that this is not is because of Jim. Shame on you, Jim. There we go. All right, let's take a look at this last one. Now, in this last one, there should be a picture. So let me go ahead and put the graph. There we go, that works. And then like so. Hang on a second. Let me see if I can make it. There we go. There are my 2 graphs. Now, when you have a graph, you can do something that's called the vertical line test, which means all you have to do is you have to take a vertical line, a line that goes straight up and down, and you have to place it through the graph. If the vertical line touches your graph more than once, if it intersects it more than once, it is not a function. So let's go ahead, and I'm going to do this with a different color than green. Let me do it with the purple. Here is my vertical line. It only intersects the graph right here. Now be careful, you don't only want to do one, you kind of want to think of more. So let me use my laser because I don't want to do a whole bunch of them. All you want to do is kind of think about moving that line. You can almost like take your pencil, put it up straight up and down, and just kind of move it along that graph. If it ever touches more than once, not a line. I don't think it's going to. I don't think there's any point on here where that's going to happen. This is a function. This is a function. It passes the vertical line test. How about this second one? Well, I can tell you if I put a vertical line right here, it's going to touch the graph here and here. This is not a function. And I'm going to write y for this one and not just explain it. I'm going to put that it fails the vertical line test. To pass the vertical line test, you can only touch the graph once. If you touch it more than once, it only takes two, then you failed the vertical line test and a you are not a function. So there's the definition of the vertical line test for you. All you have to, it's used to determine if a graph is a function or not. You just need to draw a vertical line cutting your graph of your relation and look at the points of intersection. One or more, not a more than one, not a function. One, it is a function. All right. The last thing I want to talk to you about today is talking about to evaluate. To evaluate a function, you are simply going to replace or substitute the function's variable with the indicated number or expression. Let's go ahead and do a couple examples here. So here is my function, evaluate f of x equals 3x plus 4. Remember, this is function notation. This is just a fancy way of saying y equals 3x plus 4. But it's something we more commonly see as we move up in algebra. So f of x is really y. For f of 0, f of negative 2, and f of negative 4. Notice that it says f of x, and then it says f of 0. What this one right here is telling you is that x is equal to 0, and we're going to simply substitute that in, and we're going to solve. So f of 0 means we're going to say 3 times 0 minus 4. And I could go ahead and place that all in the calculator, and I'm going to get negative 4 for an answer. For the next one, f of negative 2 means I'm going to take my equation, 3, and do times negative 2 minus 4. That would come out to negative 10. And for the last one, f of negative 4 means I'm going to replace that x with a negative 4. Oops, hold on. There we go. And I'm going to get negative 16. Okay, all I did, guys, was I went ahead and I placed this part right here into the calculator, and that's how I got my answers for all of them. Okay, let's try one more. And the reason I want to try this one is take a look at this guy right here. Okay, so same thing, evaluate f of x, and we're going to do 0, half, and negative 5. 0, half, and negative 5. All right, here we go. So f of 0 equals 5 times 0 squared minus 2 times 0 plus 1. Well, whenever I multiply anything times 0, it's going to be 0. So 0 squared, 0 times 0 is 0, times 5 is 0. 2 times 0 is 0. So I have 0 minus 0, which is 0, plus 1. My answer is 1. All right, f of 1 half. I'm going to grab my calculator, and it's going to take me just a minute here because I do actually have to put this one in the calculator. I don't have this one in yet. So let me go ahead and place this one in. Oops, hold on. I need to go find a different calculator. I don't know how to use this one that I have on my desk. So So let me go grab a calculator. From the seat. There we go. I know how to use this one. Squared minus 2 times 1/2 plus 1. I got a fraction. So I can leave it like that, or I could change it to a decimal if I choose. And my last one, now take a look at how I put in the -5. Notice how I'm placing it inside the parentheses. When I go into my calculator, I'm going to be doing the same thing. If I don't put the -5 inside the parentheses and place the square outside the parenthesis, then I am going to end up with the wrong answer. Okay, so I need to make sure that I place it in the calculator correctly. I like to write my work down before I place it in the calculator. That's because I find that if I do so, I stop myself from making a silly computation error, just a silly mistake. I got 136. Good luck on your assignment, guys.